learned so far? We learned about polar equations. And we said that, hey, let us define x to be r cosine theta, y to be r sine theta. Then we found a nice relation between x, y, r, x, y, theta. And we saw that r squared is x squared plus y squared. And we saw that tangent theta is equal to y over x. So these are the things that we saw before yesterday. Today, we're going to continue graphing polar equations. So this is our goal, is to graph polar equations. Yesterday, we did one example. Our example was graph r equals to 2. R equals to 2 is just a polar equation. To graph r equals to 2, we need to rewrite this equation in terms of x and y, or eventually use a graphing calculator, a graphing website to graph this for us. We need to raise both sides to 2. Okay, raise both sides to 2. You get r squared equals to 4. And we already know that r squared can be written in terms of x and y, which is x squared plus y squared. So x squared plus y squared is 4. Instead of r squared, I'm using x squared plus y squared. We already know that this rectangular equation is equation of a circle centered at the origin with radius 2, which is a circle in Cartesian. In xy plane, Cartesian plane, rectangular plane with center equals to 0 and 0, and radius equals to 2. So from polar equation, which was here, from polar equation, we got a Cartesian equation both of them are representing a circle of radius 2. Circle of radius 2. So it doesn't matter if you use r equals to 2 or x squared plus y squared equals to 4. Equation represents a circle of radius 2. We looked at Desmos to graph this for us. R is equal to 2. And as you can see, here you have a circle centered at the origin with radius 2. Let's make it more interesting. In today's example, we're going to graph this polar equation. Graph theta equals to 1. Okay, perfect. Theta is equal to 1, and this is a polar equation. Polar equation. So how can I write theta in terms of x and y? Take a look at your formulas that you have. You know that tangent of theta is nothing but y over x. So since theta is equal to 1, and we know tangent theta is equal to y over x, let us substitute this theta here. We get tangent of 1 equals to y over x. Well, tangent of 1, if you use your calculator, it gives you a number. This is just a number using a calculator. Okay, let's use our calculator, see what type of number do we have here. Well, using your calculator, any calculator, online calculator, or if you type tangent 1, it calculates tangent 1 for you, which is 1.5574. As you can see, it's a very, a lot of numbers are involved as decimals. But as you can see, the most important part is tangent of 1 is a positive number. So here we have a positive number. Okay, let us get back to the board. So we use our calculator, you get a positive number. A positive number. A positive number is equal to y over x. It's like writing it this way. Y over x is equal to a number like a. What is this? You saw this equation many times in algebra. Y is equal to a times x. Since a is positive, you have a line passing through the origin, and it's an increasing line. It's an increasing line. So the graph of this polar equation is nothing but an increasing line. So theta equals to 1 is an increasing line. Well, let's go over more examples. Now it's going to ask, what if we have more complex, more complicated polar equations? What should we do then?
Professor, there's 2 questions in the chat.
So suppose we have this polar equation. Question says, graph the following. Here you have r equals to 2 cosine theta. 2 cosine theta. Well, here first of all you have a polar equation, a relation between r and theta. This is polar equation. We have different options to graph this. The first option, option 1, to graph this equation, you can just use a table, give different values to your theta, evaluate your r. You end up with some points, you plot those points, and then you're done. So point plotting is your first option, but you need to have a lot of time to be able to get a precise graph. The second option that you have is to use Desmos, a graphing calculator, Desmos, or any online website or graphing calculator to graph it for you. But as a calculus student, you should be able to convert this equation into a Cartesian equation. This is a skill that you need to have. So, as a calc student, you need to be able to convert this into a Cartesian equation. So this is what we're going to focus on. What do we have? We have r equals to 2 cosine theta. What I'm going to do, I'm going to get rid of r and theta. My job is to eliminate r and theta. R and theta. Well, to get rid of r and theta, I see it this way. That if I multiply both sides by r, I can create r squared. My left-hand side can be simplified into x squared plus y squared. So, r times r is equal to 2r cosine theta. On the left-hand side, I get r squared equals to 2r cosine theta. But r squared is x squared plus y squared. So I get x squared plus y squared equals to, take a look at this. You have r cosine. I already defined r cosine to be x. So r cosine is just x. I'm lucky here. By multiplying both sides by r, I got rid of all of r and theta in this equation. So now let us simplify this more. See what is this equation? It is x squared minus 2x plus y squared equals to 1. Now complete the square by adding 1. So x squared minus 2x plus 1, sorry, this is 0, plus 1 plus y squared is equal to 1. Just completing this square. And this guy here, if I write it in compact form, it is x minus 1 squared plus y squared equals to 1. So this equation is nothing but a circle centered at 1 and 0 with radius 1. This is a circle centered at 1 and 0 with radius 1. And radius equals to 1. Let us take a look at the graph in Desmos. So r is equal to 2 cosine theta. As you can see, here you have a circle centered at 1 and 0 with radius 1. If you have time, plug in different values for your theta, evaluate your r. Theta can be 0, theta can be pi over, for example, 6, theta can be pi over 4, it can be pi over 3, it can be pi over 2, and so on, and find your r values and plot those points, and actually you see it is exactly the same as a circle centered at 1 and 0 with radius 1, which is the exact same thing that Desmos and any other graphing calculator does. They plot these points very fast that you don't see them, but it's just point plotting. The graphing calculators or any graphing, online graphing websites, they plot points very fast and they create a graph for you. So our next example involves taking derivatives. There we go. Note that here you have sine and cosine. It means that you're dealing with the derivatives of Trig functions. So let us write the example here. So first of all, our goal is to apply calculus on polar equations. Our example says, hey, suppose you have this polar equation. For the cardioid, let me work out the dictation. Cardioid R equals to 1 plus sine theta. Find the slope. Find the slope of tangent line. At theta equals to pi over 3. Okay, perfect. So here we have the polar equation. This is polar, of course. This is polar equation. And what are we looking for? We're looking for the slope. Okay, we're looking for the slope. It means that we need to find the rate of change. What would be the rate of change? And my theta is given as pi over 3. Well, last week we learned that dy over dx can be written as dy over dt, the rate of change of y with respect to t, divided by the rate of change of x with respect to t. Now replace this t by theta. So we want to find the rate of change and eventually plug in theta pi over 3 to find the slope of tangent line. Remember that to write equation of tangent line, any line, it is y equals mx plus b. We're looking for that m. What is m? So step 1, to write or to find the slope, to find m, we need the derivative. This is your very first step. What derivative? This derivative, dy over dx. So specify the formula that you're going to use, which is dy over d theta divided by dx over d theta. Note that it says tangent line at theta. So you are finding the rate of change with respect to the angle theta. Step 2. Find dy over d theta and dx over d theta. Okay, I'm looking for dy over d theta and dx over d theta. What's the meaning of that? It means that I have to have a relation between x and theta, y and theta. So to find, for example, dy over d theta, we need to have a relation between y and theta. What is that relation? Take a look at your polar equations. When we introduced polar equations, it said that, hey, y can be written as r sine theta. You know, y is r sine theta. Something is extra here. R is extra. Do I have a relation between r and theta? Yes, this polar equation says wherever you see r, you can replace it by 1 plus sine theta. Here we go. So y is, let me use a different color so you know that I use something differently. 1 plus sine theta times sine theta. So we're happy. We found a relation between y and theta. Now we can easily take the derivative. Now take the derivative. dy, d theta. To take the derivative here, we're going to use the product rule. The product rule says the derivative of f times g is f prime g plus f g prime. We need the derivative of 1 plus sine theta, 1 plus sine theta, which is cosine theta. We also need the derivative of sine theta, which is cosine theta. Okay, so the derivative of 1 plus sine theta, cosine theta, times sine theta, plus the derivative of sine theta, which is cosine theta, times 1 plus sine theta. So this guy can be written, if I factor out cosine theta, I get sine theta plus 1 plus sine theta, which is equal to cosine theta to sine theta plus 1. So this is the derivative of y with respect to theta. Take your time, write this part down, then we continue. Now let us find x in terms of theta. Again, we know that x is r cosine theta, and r is defined as 1 plus sine theta. So just substitute that here. 1 plus sine theta times cosine theta. Times cosine. Now we're going to take the derivative of x with respect to theta. Again, you can distribute these into parentheses, or you can just use the product rule. Here we need the derivative of cosine, which is negative sine. So dx over d theta is equal to the derivative of 1 plus sine is cosine, cosine theta times cosine theta. So just parentheses here, times cosine theta plus, now we're taking the derivative of cosine, which is negative sine, times 1 plus sine theta. Okay, perfect. So this guy can be written as cosine squared of theta minus sine theta minus sine squared theta. So here we go. We found the derivative of y with respect to theta, and we found the derivative of x with respect to theta. Okay, what's next? We are looking for the slope at pi over 3. So I found dy over d theta. I found dx over d theta. Now my slope m is equal to. Very well. I need to do substitution. So my dy over dx is this equation here. Cosine theta to sine theta plus 1. But theta is pi over 3. So I get cosine pi over 3, cosine pi over 3, times 2 sine pi over 3 plus 1 divided by here I get cosine squared pi over 3 minus sine pi over 3 minus sine squared pi over 3. Well, so after we simplify this, our slope is equal to minus 1. So slope is minus. And remember that when you see the posture, let me write this right here for you. Sine of pi over 3 is square root of 3 over 2, and cosine of pi over 3 is a half. So here we have r equals to 1 plus, if it's cosine, it's this way. So if you use sine, this is your cardioid. That's the graph line. So you saw that if I change it to cosine, the direction will change. Yeah, it's upside down hard if you're using sine. So you saw that if you use cosine, you get a different direction. But in our example, this is sine. So this is your graph. This is cardioid. This is the cardioid.